Alright, what's up guys? In this video we're going to pick up with some calculus here. We're going to be on the topic of conic sections. We're going to be talking about the ellipse. So we're asked to find the equation of the ellipse that has a center 3, -4 and a major axis of length 4. An endpoint of minor axis 3, -3. Alright, so you guys have probably seen conic sections before in algebra or maybe geometry in high school. Maybe you did a brief visit of it from high school. You're going to do a bit of a brief review of it in calculus too, because you need to be very familiar with conic sections. You need to be very familiar with certain types of figures, such as ellipses and parabolas and things like that, because you're going to be working with those types of figures throughout your time in calculus. So in calculus 2, they're going to go through and do kind of a brief review of the whole conic section stuff. Like, again, you may have seen this stuff before, but they want to rehash it just so that you are familiar with stuff like this, because you're going to be playing around with these figures quite a bit. So you'll see this again, but they won't spend much time on it. So the first thing is the equation of the ellipse. So we'll get that out of the way. Alright, so equation of the ellipse. And this, of course, we have a horizontal, that is, we have a horizontal major axis. Then we know the equation of the ellipse will be x minus h squared. There's going to be a plus sign all over a squared. It's going to be y minus k squared all over b squared. That's equal to 1. Okay. So the first thing we need to do is identify the center. They did give us the center. So remember, for the center, that's going to be h comma k. So that means that in this particular case, it was 3, -4. So in this particular case, h is going to be 3 and k is -4. And the major axis is length 8. Now, since we're given a major axis of length 8, that means that we could set 2a equal to 4 and solve for a. And if we solve for a, we divide both sides by 2. And that means that a is going to be equal to 2. Okay. It's an extra sheet, so we need it. Okay, now let's go to the endpoints of our minor axis, which were 3, -3. And basically what we need is, we need to find b, basically. Okay. Which was 3, -3. Now remember, the value b is just the distance between the center and the endpoint of the minor axis, which we're given up here. So what we need to use is the distance formula to get that. So hopefully remember from algebra or geometry or wherever it is you learned it, the distance formula, remember, that's just d is equal to, and d here, we can think of it as representing, we can think of this as being b, just the actual distance formula, that be d is equal to. In this particular case, we're looking for b because, again, b is just the distance between the center and the endpoint of the minor axis. So just imagine d as being b. That's essentially what we're solving for, but I'm just being technically correct. And remember, it's going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, so it's just a bit of a substitution process. That's the actual formula. I guess I'll write it this way to be a little bit more specific. So in our particular case, let's go ahead and do the subtraction. So it's going to be 3 minus 3 squared plus -4 plus 3 squared. And this gives us the square root of 0 plus 1. Okay, because Negative 1 squared is 1, and 1 squared is 1, obviously. So essentially here we get the square root of 1, which we know is just 1. So that's actually going to be the value of b. So now we have the value of a and the value of b. And now we can easily substitute in for the equation of the ellipse. So looks like we'll have x minus 3 squared all over 2 squared. Then it'll be plus y plus 4. Remember, it's supposed to be a minus there. Remember, k was negative 4, so 2 negatives give us a positive, just if you were wondering about the formula. And that's going to be squared, of course. And then that's going to be all over 1 squared, and that's obviously going to be equal to 1. And I'm going to write my final answer over here. We just simplify it, and that'll be the equation of the ellipse in this particular circumstance. So we try to fit it in here. So the equation of the ellipse is going to be x minus 3 squared. 2 squared is 4, so this will be all over 4. And then this will be plus y plus 4 squared all over 1. And I'm fill it in there, it's going to be equal to 1. That would actually be the equation of the ellipse in this particular case. Actually, I'll write it up here as well, just in case you can't see it that far down. So again, equation of the ellipse is going to be x minus 3 squared all over 4 plus y plus 4 squared all over 1, and that's going to be equal to 1. So that's the equation of the ellipse. Just kind of wanted to rewrite it because we ran out of room. Alright, so that is your answer. So like I said, let me know if you have any questions about it. Relatively straightforward activity. But again, you will get a brief review of this type of stuff in Calculus 2. And your calculus textbook should also have a section. I mean, I could be wrong, but should also have a section. I have the, I've already graduated, but I have the Pearson edition when I was completing my physics degree. I just went ahead and bought the textbook and kind of kept it instead of turning it back in. So maybe you got a different one, maybe your professor used a different one, but there should be some conic section area within the book. You look at the table of contents, and it should be a very brief review of not just ellipses, but parabolas and everything like that. Okay, guys, I will see y'all next time. Let me know if you got any questions. Y'all take care.